This is the PIXINSIGHT process tutorial for the photometric color calibration. You find it in Process, Color Calibration, and here it is. From my point of view, the photometric color calibration is the most unique process of PIXINSIGHT. If I have to state only one thing that PIXINSIGHT can do that practically no other software can do, it's this one. So what does it do? It calibrates the colors in the pictures based on the real colors of the stars. And the unique thing is that it really does it by the real colors of each and every star. And for that, it plate solves the picture so that it really knows where it is in the universe. And then with a second database, it actually gathers for each and every star the correct color and assigns it to it. And that's way better than, for example, AstroPixel processor, who has a similar model, but they state they do it on a statistical distribution of colors, which means they just know probably 20% of the stars are blue, so every fifth star we give a blue color. I might simplify that a little bit, but in principle it boils down to that, which means it doesn't reflect the reality at all. And here it is 100% the reality what you have afterwards on the picture. So as you can see, this is a huge process with lots and lots and lots of features. And while in most situations you get through with only a few changes, it still is worthwhile that we look at it in detail from top to bottom. So let's start from the top. This is something probably most people ignore, and righteously so, they do that. Actually, you can change, it's interesting, you can change the working mode from broadband to narrowband. So if you're using narrowband filters, you can actually state what narrowband filters you use, the bandwidth, and it should actually use that for the color calibration. Now I tried it out, and it might be just me, but I didn't saw any difference at all. So if it's really worth doing that, I don't know. Personally, I don't do it. Also here you can change the white reference. So they state that an average spiral galaxy reflects in the best way a reference to white, and then everything will be calibrated based on that. Usually it works fine. You could actually experiment with that if you feel that the color hue that you get throughout the whole picture is off. I would say 99.999% of the cases, this is fine. So first section, you don't really have to touch it. Now the second section is the one which is probably the most familiar if you have ever used this process, and it's also the most important. Because here you actually tell the plate solving instance where they should look for in space. So for example, here we have a picture of M2. So it's quite easy. I go here, search coordinates. I enter M2, enter, and already says M2. It found it, get it, done. Now it knows the coordinates where this is actually located. I also have to tell them the date. So this was actually shot at October 17th, something, whatever, time is okay, middle of the night. You have to tell them the focal length of your telescope, and don't forget if you have a reducer on there, it's different. For example, my CPC 800 has 2050 as a focal length, but with the reducer on, I have only 1350. And last but not least, you have to tell them the pixel size of your camera. If you don't know that, just go to the homepage of your manufacturer and look it up. It's stated by every Astro camera. For my ASI 2600, it's a 3.76 pixel size. So that's crucial that you get that right. Now let's go to the next stage. Here we define how the plate solving is done. And as a default, you will find this here selected automatic catalog. And now once you've finished this video, I hope you will finish it, then please go to to my process review Gaia, and it will tell you how you can actually install the database on your computer. And then you can actually select it here, the XPST, deselect automatic catalog, and the advantage is from now on, this process has not to go to the internet anymore to find the data, but it can immediately get it from your computer. It's much faster. Otherwise, leave everything as it is. Advanced plate solving parameters, for the moment, leave it as it is. This is only if you have trouble. Next section, photometric parameters. Now, what you need to know is that the plate solving part here only tells the process where this picture is located. So this is star XYZ and so on. But it still doesn't know which color it has. So what it does, once it knows how all these stars are called, it goes to a second database, to a photometry database. And there it finds the information of the color of the stars. And this is in here. So here the same thing. Once you finish this video, once you finish the Gaia video, just go to the APAS video. And there I will tell you how you can do the same thing as you already did with the Gaia, also with the APAS. Advantage again, instead of having to go to the internet, download all the data, it can get it right from the database on your computer. Much, much faster. Otherwise, leave everything as it is. And now we come here to this lowest part, which is background neutralization. And that leads to a lot of confusion because people do not understand if this is now the same as the background neutralization process. So if they have to do the background neutralization before they go into photometric color calibration. The point is, it is 100% the same. So if you do photometric color calibration, you do not have to do background neutralization before. And that's another convenience of this process, that this is included. Now you might argue that when you do actually a separate background neutralization before and not use this process, you have the better control as you see what's coming out of it. The issue is, and that's my experience, that if you do it that way and you do not use background neutralization, even you have neutralized the background before, you get some really strange off-colored results. So it looks like photometric color calibration that does not appreciate if you do not do it the background neutralization. So keep this on, and if you use this regularly, you do not need the background neutralization as a separate process anymore. And as with the regular background neutralization process, you still have the option to say that you only want the lowest 1% to be used as a background, or you can actually select the region of interest, create a preview, and then use this. Here, as it is a quite straightforward picture, there's no nebulosity, it's only stars, I can easily leave it at this and it should do fine. Okay, with that said, let's put a triangle on there and let's see what's happening. Okay, and here we have our picture. First of all, you might wonder, what is this? In principle, it just shows you if the stars were like expected or if you have some outliers. At the end, it's a nice little gadget, but not really needed, so just close it down. Second of all, you might be absolutely shocked and you might go like, oh my god, what happened with my picture? That looks terrible. Well, it just looks terrible for a second, just stretch it again. It's fine again, looks almost like before, but the stars might be sparkling now a little bit more colorful, or at least in the accurate color. Now this could already be the end of the story, the end of this video, but it isn't. Because time and time again, people are complaining and have huge issues because photometric color calibration does not do its job. And I want to show you how this can look like. So here there was a happy end, everything's fine. So let's close this down and let's open up another picture. So if we look at this picture, there's a million of stars. So it shouldn't be any issue at all to actually plate solve it. So first of all, here it's not that clear. It's a part of the Veil Nebula, but that's just too big, as this is only part of it. And so we have to see what to tell now the software where this is. So for that we go to a planetarium software. I use Starry Night. I already entered here Western Whale Nebula. Here we have the whole Whale Nebula, and it's not really the western one. It is actually this triangle here, which I made a photo of. So we have to be a little bit careful here because the NGC 6960 is the whole Western Whale Nebula, so that might still not be precise enough. So, but for example, here the LTN 864, that's very specific to this area. So I think if you use this one, we should be fine. LDN 864. So we go back to PIXINSIGHT, LDN 864. And so it found it. We say get it. Okay, and it's fine. It was actually shot a day later than we have here on the 18th. That's fine too. Rest is good too. Okay, all is fine. We're happy. So we actually throw the triangle on there and let it do its job. And usually when it starts to go that fast as now, something is wrong. And you see, previous attempt failed. It's like the blue screen in Windows. You get this nice little statement, unable to plate solve image, alignment failed. What are we going to do? We have to figure out what the issue is. And the issue can be manifold. Reason number one, you could actually typed it the wrong way so that it actually looks for something else, another place in the sky. It's not the case here, that's fine. Second issue, you might have made a mistake with the focal length or the pixel size. I once actually made a mistake with the date. I just wrote 2020 instead of 2022. That will also not work. Another thing that might actually happen is if you crop the picture too much before you do that. You might also have an issue because this ratio doesn't work anymore. So a little bit of cropping is fine at the beginning, but don't radically crop the half the picture away. It will have an issue with it. So this is one thing to rule out, and here we ruled it out. Everything is fine. The second thing, and I want to give here a credit to Adam Block, who put a whole video about that in the net, and I will put a link in the description below. Sometimes here in the plate solving or photometry parameters, it might have an issue with the databases. And so if it doesn't work like that, you could actually select here automatic and see if it works better. Or here, for example, you could go to APAS DR9 and try it like this. And sometimes he states that helps. Now I tried that before, and in this case it doesn't help. It still is stubborn. It will not plate solve it. So the last thing you actually can do is you can change stuff so that it helps it. For example, here, distortion correction. You can select that. Didn't help here, but might select if your picture is distorted. Next thing you can do, you can add a noise reduction if you have a very noisy picture, so that PIXINSIGHT can easily look through the noise. But what I felt what really helps most is you see this triangle similarity. And if you change this to polygon matching, this is more powerful. It needs more time, but it's much more powerful. And I will now let it run with the polygon matching on. Okay, and now it finally worked. So what is the lesson learned here? I think don't give up. If it doesn't work, it usually will work in one or the other way. Just go systematically to these few areas which I showed you now, and just try to figure out where the issue is. And sometimes it needs trial and error, and that takes obviously some time, as this process takes some time, but it is quite worth it. Obviously, if after 5 or 6 tries nothing works, you can always go back to a usual color calibration. I hope this was helpful. If it was, please give me a like and hit the subscribe button. Thanks a lot. See you next time, and clear skies.